Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 11, the container with most water. This is a classic two-pointer problem, an absolute favorite in technical interviews at top-tier companies like Meta, Google, and Amazon. Let us look at the problem statement. We are given an integer array called height, where each value represents the height of a vertical line. Our goal is to find two lines that, together with the x-axis, form a container that holds the most water. Keep in mind, the width is the distance between the lines, and the height is limited by the shorter line. Think of it like building a swimming pool between two skyscrapers. The water level can only go as high as the shorter building. If you try to go higher, it simply spills over. To maximize the water, we need a balance between a wide base and tall walls. Now, let us dive into the algorithmic strategy. A brute force approach would check every single pair, but that is too slow. Instead, we use the powerful two-pointer technique. We start with one pointer at the very left and another at the very right. This gives us the maximum possible width. Here is the golden rule: at each step, we calculate the area and then move the pointer that points to the shorter line. Why? Because moving the taller line can only decrease the area, but moving the shorter one gives us a chance to find a taller boundary that might compensate for the shrinking width. Now, let us walk through the dry run. Look at the screen. We have our heights array, and our max area tracker. Initially, left is at index 0 with height 1, and right is at index 8 with height 7. The width is 8, and the height is the minimum of 1 and 7, which is 1. Area is 8. We update our max area to 8. Since 1 is less than 7, we move the left pointer. Now left is at index 1 with height 8. The width is 7, and the minimum height is 7. Area is 49. That is a huge jump. We update max area to 49. Next, we compare index 1 with index 8. 8 is greater than 7, so we move the right pointer inward. Right is now at index 7 with height 3. The width is 6, and the minimum height is 3. Area is 18. 49 is still our max. We continue this process, always moving the shorter wall, until our pointers meet. By the end, we have explored all potential candidates efficiently. Now, let us look at the Python implementation. We initialize two pointers, left at 0 and right at the end of the array. We also keep a variable, res, to store the maximum area found so far. Our while loop runs as long as the left pointer is less than the right. Inside, we calculate the area by taking the width, which is right minus left, and multiplying it by the minimum height of the two boundaries. We update our result using the max function. Then, the crucial step. If the left boundary is shorter than the right, we move the left pointer inward. Otherwise, we move the right pointer. This greedy approach ensures we never miss a potential maximum. Looking at the complexity, the time complexity is O of n, because we traverse the array exactly once. The space complexity? O of 1, as we only use a few variables for pointers and the maximum area. And that is the container with most water challenge, mastered. Save this video for your next technical interview, and follow Leo Academy for more 10x premium DSA guides.